This video is a guided tour of PAI's basic training services, focusing on our Introduction to Plant Unit Operations module, an off-the-shelf computer-based training program customizable to the design and function of your facility. Our basic training services include 6 components: Introduction to Plant Unit Operations, covering topics such as crushing, conveying, flotation, solvent extraction, and plant safety; Introduction to Mining, with such topics as ore bodies, exploration equipment, drilling, planning, and environmental issues; Introduction to Basic Mechanical Skills, covering topics such as welding, pipe fitting, rigging and lifting, conveyor belts and bearings; Introduction to Mobile Equipment, including topics such as haul trucks, wheel loaders, excavators, as well as components such as hydraulic drives, hydraulic systems, and torque converters; Introduction to Process Control, which explores interlocks, sensors, controllers, and control devices; and finally, Supervisory Skills Development, which guides you through the management process, including planning, leading, organizing, and controlling, as well as key performance indicators, opportunity costs, and shift control methods. In this video, we'll focus on our Introduction to Plant Unit Operations module. Using narration, graphics, videos, simulations, and 3D animations, this module serves as a basic training tool for newly hired plant operators, as well as a screening tool for prospective operators. The instruction and assessment format tests comprehension of key principles of a variety of plant equipment and processes, including crushing and conveying, dust control and pumps, and the operation of an autoclave, for instance. Here, Ryan walks you through and highlights some of the features of this training module.
As we discuss further the topics that are covered in the basic or fundamentals training, today we will be focusing on the Introduction to Plant Unit Operations. This introductory module is tailored for plant operators, though the information is beneficial to maintenance and supervisory personnel. As you see here, this is a list of key topics that is covered in the Introduction to Plant Unit Operations, from fundamentals through crushing and conveying, dust control and pumps, through specific processes for gold and silver, for electricity and safety, solvent extraction, electrowinning, pressure oxidation. By expanding here, we can see the variety of subtopics that are covered under each key or main topic. Selecting on the first one for pressures and pressure drops, you will notice that all modules begin with learning objectives. These learning objectives are the desired results for the trainee and/or trainer as to what is to be learned during this segment. The look and the layout, you will notice there is text on the left with supporting graphics, and then there are graphics on the right. On the right, we will also see the option for other videos. As a trainee scrolls through and is learning the given topic, there will be various links that will help to support and enforce the material and content that is being learned. If you notice here at the top, there's a toggle workbook. This workbook has a variety of questions. These questions can be answered. Though these questions are not being graded, they are being noted as either correct or incorrect here for benefit of the trainee. Green signifies that the answer was answered correct, and red means it is incorrect. This supports training either on an individual basis, where a person has just accessed the information and is learning on their own, or in a class setting. They can toggle back and forth between the content and the workbook, read their answers, review the answers that they've answered incorrectly, go back to the content, find the correct answer, and make sure that they understand the material that is being presented. Showing forth a few other examples: crushing and conveying, from gyratories and cones and jaws through belt feeders and apron feeders and so forth. Let's select a cone crusher. Learning objectives. In this case, you will notice graphics on the right, other images, supporting graphics to display, in this case, the gyrating motion, the adjustment of the gap, the hydraulic system controls, release mechanisms, lubrication systems. If you'll notice this red link, there's a 3D animation that is voice narrated.
Secondary stage or tertiary stage of size reduction in a modern mining operation after the material, usually ore, has been initially reduced in size by a primary crusher in the first stage. Normally the primary crusher will be either a gyratory crusher or a jaw crusher.
This 3D animation will continue to break down the cone crusher, display its parts and its main functions, how the crushing action works,
have been designed so that the feed material will undergo a series of hits or blows before it actually discharges out of the adjustment ring from rotating during the passage.
hydraulic systems and support systems.
The main frame pins also serve as a guide to reseat the adjustment ring, returning it to its original ambient temperature.
Lubrication systems.
If the system is fitted with a radiator type heat exchanger, the oil is cooled when a fan activates and a preset drain.
All of these animations and videos are providing support to learning the basics and fundamentals, in that case, of a cone crusher. Dust and mist control. For example, how does a pulse bag type dust collector work? Our associated learning objectives. Principles of dust collection, different types of media and screens and tubes that are used, pressure differentials, as well a very simple 2D animation. Notice dirt being pulsed off by the pulse air off of the bags, and a blow up of the bag surface. Also, many facilities have pumps, horizontal centrifugal, vertical, positive displacements. Sometimes pumping is a hard concept to understand. In this case, what is a horizontal centrifugal pump? What are the main components, key parts? Packing. What is static head? Head pressure, a typical pumping system. High friction, low friction. As well, in this case, a very simple simulation. Here you see the pump curve, associated butterfly valve, the brake horsepower, flow meter, head. Right now that valve position is closed. What happens as we begin to open the valve? How is that affected on the curve? Noticing that the more the valve is open, the head decreases, while flow and horsepower increase. There's also narration that goes into further description of the horizontal centrifugal pump. Grinding, another key aspect. Introduction to grinding technology. Why do we grind? What is the metallurgical purposes to grinding? Sag mills, for example, is one that is used in the mining industry. Various pieces of the sag mill, components, optimum loads, underloaded, overloaded. Again, teaching the basics and the fundamentals, in this case, for a sag mill. And we have an associated animation that will animate the use and operation of a sag mill.
Fixed, while the non-drive-in trunnion bearing is floating. The trunnions are bolted to the mill shell and be reduced in size. The grinding within a sag mill also causes abrasion from the teeth of the pinion mesh with the teeth on the ring gear, causing it to rotate. Draw oil from the dirty side compartment.
Hydraulic systems and all supporting systems as well
Relief valves protect the
on the sag mill are covered.
discharges into 4 equal parts among the 4 bearing pads. Each pad has 5 hydrostatic lift pockets, a large center pocket. The operator manually switches to the standby filter and cleans or replaces the dirty filter. Or it can be a hydraulic drive.
All the way down to the engine drive.
Must be manually engaged using a locking system.
Another common process in the mining is flotation. Our introduction to flotation technology helps us understand the different phases, reagent classes and functions, the purpose of bubble creation and bubble dynamics, as well as froth dynamics and froth management. As we get into various
phases,
reagents and classes,
flotation process
we can use different modifiers, activators, depressants, and pH regulators.
Depressants. Many of the depressant reagents are performing a task that can be called deactivation. Commonly used examples of depressants are sodium.
And these modules are also voice narrated to reduce the stress of reading. One last one that I wish to show today. Here down in pressure oxidation, a very specific process using the autoclaves. Again, beginning with the learning objectives. The autoclaves, what they are, what is the purpose of pressure oxidation leaching for sulfide ores, its autoclave size and different compartments, the inside of an autoclave, various service nozzles, temperature and pressure relationships, as well again a high quality 3D voiceover animation.
An autoclave is a vessel that treats ore or concentrate by providing high pressure and high temperature conditions that in practice, the flow of oxygen required by the autoclave is calculated according to the amount of sulfide in the ore conditions of atmospheric pressure at sea level. The boiling point of the pump described in this animation is a reciprocating positive displacement pump. Is also not resistant to the corrosion that would occur if it were subjected to the extremely acidic condition of the autoclave. Each agitator shaft must extend through the steel shell and brick lining. Gases are discharged from the autoclave through a vent line. The slurry has been prevented from boiling by the high pressure of the autoclave and the relatively high pressure of the blast tube.
As you will notice, all of these topics serve to create a very sound, fundamental, basic knowledge and understanding of key principles and fundamentals of not only equipment, but as well as metallurgy and process within a given plant or facility. Without these basic understandings and this knowledge, it is very unlikely that any operator will be truly successful in operating the plant that they've been designated to operate.